Video lesson 12.1, mean median mode. So today we're going to talk about measures of central tendency, which is these, specifically these three things: mean, median, and mode. But before we get into that, just take a second and think about the do now. Like if this was something you had to do on your own, which you could do for yourselves, how would you calculate the test average for Robert with these 5 grades that he has? All right, what would you do? You'd take them, all right, and to find that average, you'd simply add them all together. So we take all of these, add them together, and then you would divide by the number of exams that he had. So in total, it'd be 1, 2, 3, 4, 5. So we'd take that, we'd simply divide them by 5. So if I add those all up, take a quick second to plug that in. If I add those all up, I get a total of, I'm getting 385. If I divide that by 5, that comes out to be 77. So I'd have a test average for Robert, which would be 77, right? That's your average, right? That's your mean, right? That's what that represents. So if you think over here, the mean, that's the numerical average. Right. So again, to do that, we've done that, I'm sure, many times before. You do it probably all the time to figure out what your averages are in your classes. Just simply add up all the scores, divide by the number of scores or the number of pieces of data, and that is in fact your average. But that's not the only piece of information you can get out of this stuff. Right? There's other things as well. All right. Your median, right? That's the number in the middle. That's the middle value. And it's the key thing here is it's when the average is arranged in numerical order. So if you have everything here in numerical order, the number that would literally end up being in the middle would end up being your median. One little note, and we'll get to this in an example or two, but if you end up with 2 values in the middle, you simply just take the average of those 2 numbers, okay? But again, we'll get to that in a little bit later on another example. The other piece of information that we're going to talk about for today is the mode, and that's the number that occurs the most, right? So think mode, most, all right? So it's a repeating portion. There can be more than one mode, and there is a possibility to have no mode from there. So it's as long as you have the same, whoever has the same amount of those things, so frequency of that specific piece of data. So if you've got multiple scenarios that represented the same thing, then you could have more than one mode. But, like for example, right, in Robert's example, all of his test scores are different. If he had gotten, let's say, an 82 twice, then that would be his the one that became the mode would be 82 because you have 2 with the same score and nothing else would have a frequency of 2. So that's the idea. All right. So if you look at some of the examples, so if we go back to the do now real quick, right? We just already found in this one here, we did that up above. So the mean, as we already found, or aka the average, was 77, right? So the mode, right? The median, The median, right? That's the one when dealing with the middle. What number's in the middle? So again, if they're in numerical order, which they are here, if I simply start basically taking them away from the top and the bottom. So best thing to do is just write them in numerical order, right? And then cross out 1 at the bottom, 1 at the top, right? And I'm going to keep doing that. So I removed the highest and lowest score. Now do it again, right? And I keep doing that until I get into the middle. So until I get 1 here. So again, if it's just one number, then you know that's your median. So in this case, the the mean and the median are the same. Not always the case, so keep that in mind. If I did get 2 numbers, I would just simply average those 2. All right. In this case, as we already kind of indicated before, the mode, there is no mode, right? Because there is no duplicates. Nothing is happening more than once. Everybody just has a single score here, so there is no mode. Okay. All right, let's look at the next one. All right, so we've got our mean, All right, we've got our mean. And what's that going to equal? So I'm going to add up all of these values here. So I've got what's happening here. Let's add these all up. So 8 plus 9 plus 8 plus 4 plus 3 plus 7 plus 0 plus 3 plus 1 plus 2. And I'm going to divide that all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So if I add that all together, so when was that 45 over 10. So that's going to give me a mean or an average of 4.5 for this data. Now, this data has no context right now, so I don't know what the 4.5 represents, but we just know that it has an average of 4.5. The median, right, if we were looking for the median, right, I can't just start crossing out like the top and the lowest one here and go from there because they're not in numerical order. So I'd have to rewrite this list, right, from here. So I'm just going to rewrite this. I've got 0, 1, 2, 3, got another 3, there's a 4, 7, there's 2 8s, and a 9. And again, I always go back and check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 pieces of data. That's what I should have. And I would go back and just double check that I've done it. So now I can start doing this. So I'm going to cross off highest and lowest. Again. All right, so now I get down here. So here I got both of these numbers. All right, if I cancel them out, I got nothing. So I'm down to 2. So now I'm going to simply find the average of that. So 3 plus 4 divided by 2. So that's 7 divided by 2, which gives me, was a 3.5 for our median. All right, so that's an example as to where when I do cross them out, I end up with a pair in the middle, find the average for that. All right, last but not least, the mode, which happens to be the most. Again, I like to do the medians. If I have to do it, I like to do the median first because I now have a numerical order. I can kind of look here, and you can notice easily I had a pair of 3s. I also had a pair of 8s. So out of all the pieces of data, I had 2 of each of those. So that represents my modes. So I've got a 3 and an 8 were my answers because those are the ones that had the most frequency within the set of data. So that's the process. That's your mean, median, and mode. And that's how you're going to find each of those things. It's one of those things that you just got to take your time. Be informative as to which process goes for which term. So again, vocab is important here. But that's really it. All right. For these 3 pieces of central tendency, there's other stuff that we can do with the data. There's a lot of stuff that we can do with the statistical part of this. But for right now, we're just starting off a little slow. So this is the information that we've got that we're going to work with here. All right. Let's look at another example. All right. We've got a collection of data from 4 employees at a company. The results of the study based on each worker's age and salary are listed below. So determine the mean, median salary for the employees here. So they're doing a comparison here, all right? So we're looking at each one of these things. So let's start off by taking the, it doesn't really matter which one. I'm going to do the mean first. So we'll do the mean. So I'm going to simply just add all of these up. And we're going to end up dividing by 4. So there's 4 pieces of data that we are doing here. In this case, 4 employees' salaries. All right, just going to use my calculator here, add these up. And I get Let's see, that comes out to be 124,775. If I divide that by 4, I get 31,193 and 75 cents. It's money, so I'm going to put my $sign here. So that is the mean, the average salary based on the information that we are given. So now if I do my median, now I'm going to simply write them in order here. So I've got, well, actually, it's done for me, but we'll write it out, right? This data set did actually give it to you in order, which is nice. Not always the case, so you do have to be careful, right? So across the top and the bottom out, I'm left with 2 on the inside. So now if I simply take those two things and find the average of them, so we're going to get 30,000 plus 31,275. Divide that by 2. That gets me 61,275 divided by 2. It's 30,637 and 50 cents. So that's the piece of information. Now notice that the data, the results I should say of the data, are similar or close to each other, but they're not the same, right? The mean and the median are not always going to be the same. We saw that in the last example as well. But it is possible for it to be, which happened in the first example. But a lot of times we need to take. So why do we even care about the difference of the two? So the main reason we care is that there can sometimes be some outlying information, something that's an extreme based on that scenario with this, So it could be, something where, if you're, looking at this set of data here, maybe, there's this extreme scenario where, somebody comes in, based on what data we have here, they got the ages of these people and how much they work. So this one looks like as they get older, they have more experience and they get paid a higher salary. But what happens if somebody comes into this company with an extremely high degree? Maybe they're like, 23 years old, just out of college, but they have an extremely high degree and they have take a high position with a high salary. That could skew the data a little bit. So sometimes we want to interpret and look at the information in both cases to see if there's any reason or any outlying information that may cause something to be one extreme or the other. I think for you guys, if you think about your test scores or things like that, that's a good way to kind of think about it. Like you could have your average, your test average. Say you're averaging something in the 80s with your test scores. But then all of a sudden you have a terrible day and you forgot to hand something in and now you have a 0 for it or something like that, and all of a sudden you see your average drop a bunch. That is an example of how that can affect you dramatically in some cases. So the more extreme the data is, or how far off that new piece of information can skew the rest of the data. So we want to be able to kind of look at it and sometimes determine if there's a justification for that change. Sometimes it's valid. Sometimes you might be like, well, that was an extreme scenario. Let's take that out of the equation or ignore that part for this interpretation, something like that. All right, let's look at a couple quick examples, and then you can look over and take some notes and make sure we have a good understanding of this. All right, so we got Mary here. She's got looking over her quiz scores for the first and second quarter. So which quarter was Mary's mean score greater? So all we're doing here is a comparison. So we're looking for that information based on each of them. So we're just looking to find the average for each quarter and then do a comparison of that data. So Q1, I'm just going to do here for the first quarter. Let's add up all of these. All right, all together. And let's see if we add all that up. That is 428. There was 5 pieces of data. So if we use the calculator here, 428 divided by 5 gives me 85.6 for her average. For the second part, for Q2, let's add up here. She's got more scores here. All right. In this case, she's got 7 scores in total, so 2 more quiz grades here. So that's going to be a total of, this came to 594. If we divide that by 7, I get 84.9. So in here, right, looking at this data, we've got the 85.9 is greater, that's a bad symbol, greater than 84.9. Therefore, Q1 has the higher mean or higher average. Okay, so just something we can do. We can do a comparison of the information provided. And that's the same thing with number 5. All right, they can ask us to do all of this same kind of a thing, and then based on here. So on these questions, and I love these questions, I would just simply ignore these for a second, do all 3 of them, and then go back and compare the to the information that you have. So let's just take a second and do that ourselves here. So let's say here the mean, come up with what that is. I'll give you guys a chance to just take all of this data here for a second and calculate all of that. And I get a average of 81.6 when I do that. Then I'm going to do my mean. So my median. All right, I'm going to do this. I'm going to have to put this in order again. So again, smallest one here is 63, 69, 76, 76, 78, 81, 85, 89, we have 90, what's that, 94, and 97. Again, I just count real quick, make sure I got all 11 pieces of data. Good, so start crossing off top and bottom, highest, lowest. Oh, I come out, just a nice one, so that gives me an answer of 81. And last but not least, my mode, which again, since we already have it here in order, it makes it a little easier to do. I notice I got 76 twice. Nobody else has a duplicate, so 76 is in fact my mode. And now I'm just going to take all 3 of those pieces of information and check each one. To go through here. So I would literally just go down the list. Choice A, is the mean greater than the mode? Is 81.6 greater than 76? The answer is yes. Okay, done. There's your answer. Okay. Of course, as somebody like me, I like just to double check to make sure I didn't make any mistakes. Is the mean less than the median? Is 81.6 less than 81? The answer is no. That would have failed. Is the mode bigger than the median? Is 76 greater than 81? The answer is no. And is the median equal to the mode? These are not the same, so therefore that one failed. Again, reassuring that answer 1 is in fact correct. All right, 2 other quick things, and we are getting a little lengthy here on the video, so I won't go through everything crazy. Let's But let's just look at this one real quick, just because I want you to see one little caveat that you got to make sure you're careful with. And that is when you're given data and they are giving you a frequency of the data versus all the data out in one thing. So here they're giving you the values of the houses, but they're giving you the total number of houses for each of them. So if I went to do the mean here, right, it's asking for what the mean and the median is. So if I go to the mean, I can't just simply add up like we did before, just add up these 4 scores and divide by 4. That's not how many pieces of data there are, because this tells me the number of houses. So I'd have to add up this whole line here. So I got 10 pieces of data in total. So if I'm dividing by 10, right? All right, if I'm dividing by 10, that means I need 10 pieces of data on the top. So I got one house at 100,000, but I got 5 houses at 175,000. So I could write that out, and I could literally write out each one of these altogether. But we can shortcut. We can say 100,000 plus I could do 175,000, and I can just multiply that by 5. Right? Make it a little faster, so instead of adding it up 5 times. I've got 200,000, and there's 4 of those, and then one of the houses at 700,000. Right? So that's, you just gotta be careful when there's a frequency of the data. We gotta make sure we include all of those. Again, if you want to just simply add them all together, just 100,000 and then 175,000, and you add that 5 more times, and then 200,000, add that 4 times, and then the 700. That's fine. But again, you can just shortcut it by multiplying. So let's just do this real quick here. I'm getting to 24. Another 100 is, what is that? 2,475,000. Divide that by 10. Oh, I'm sorry, not 10. I'm sorry, 11. Oh, I miscounted that before. There's 11 pieces of data total. So if I do 2,475,000 divided by 11, I'm getting an average of 225,000 for that one. My median, right, equals, again, I got to go through here and I got to count all of them from there. So I'm just going to kind of abbreviate each. So I got 100, I've got 175 5 times. I got the 200 4 times, and then the 700, right, for that one. Pen keeps smudging there. There we go. Again, highest, lowest, keep going. I end up with a median of $175,000. So you can see here, right, in this case, which one represents, the question here says which one represents the best information based on the data. Is the 225, kind of justify all the values, all 11 houses, or 175 a better representation? And in this example, based on the in here, the 175, the median, is actually a better choice here because it's closer to the actual values that's going on. The reason the average jumped up here is because of this one simple thing. You've got this one house which has an extreme in comparison to the rest in terms of its values. So the average here gets skewed a little bit, kind of bumps up higher than most of the other ones. Because look at them. All of these here, right? The majority of your houses, 10 out of the 11, would all be underneath the 225,000 mark. So is that really the average? It's not, right? It's not really the average of all of these. This $700,000 house made that average increase, so it doesn't really give you a true representation of that data. So in this scenario, the median would be a better choice. All right. And that's what you're looking for. That's where the interpretation comes from, and we'll utilize that more within this unit. But this is the first lesson for this unit, so take a chance to just make sure you understand what mean, median, mode is, how to calculate them, and then again we're going to work on and even more going through how to interpret that data. All right. Well, don't worry about number 7. We'll just do that one another time. All right.